Today we're on page 6 of our chapter 16 notes packet, section 5, at least and at most. So this is going to be one step beyond what we did yesterday in class. So we're going to continue to use the formula from yesterday, the NCR, P to the R, Q to the N minus R. But we'll have at least or at most in the probability questions we're being asked. At least 5 means if you have at least $5 in your pocket, that means that you have 5 or more. At most 5, if you have at most $5 in your pocket, that means you have 5 or less. We're going to be calculating at least and at most probabilities. A coin is biased. That means it's not fair. It's not equally likely. It's not a 50-50 chance of being heads or tails. A coin is biased so that the probability of obtaining heads is 3/5. What is the probability of obtaining at least 3 heads and 4 tosses of the coin? So at least 3 heads and 4 tosses. Well, at least 3 means 3 or more. And 4 is our n value, the number of tosses. So n equals 4. R is 3 or more, so 3 or 4. We can't go over the number. We can only go up to the n value. Can't go over. Probability of getting a head is this biased amount to 3/5. So that means the probability it's not a head, or the probability it's of failure, is 1 minus 3/5, or 5/5 minus 3/5, which is 2/5. Remember, your P and Q added together would always add to 1. Okay, so we have to compute the 2 separate ones and then add them, because when we're working with probability, or means add. So we do NCR, P to the R, Q to the N minus R for R value of 3, and then for an R value of 4. So this would be 4 C3, P value is 3/5 to the R, Q value is 2/5 to the 4 minus 3, which is 1. I'm going to save the time of keying that into the calculator and just tell you that it ends up resulting in the fraction 216 over 625. Plus, next we want an R value of 4. 4C4, 3/5 to the 4th, 2/5 to the 4 minus 4, which is 0. Key that into the calculator. The result is 81 over 625. Okay, and now add these. Same denominator, as it should be. Now sometimes if fractions can be simplified, the calculator will do that for you. Oftentimes, if the numbers are small enough, I'd rather work this out by hand, because the denominators should be the same. If they're not, then you did something wrong. So 216 plus 81, that's 297, which matches option 4. Number 2, a fair die is tossed 4 times. Find the probability of getting at least 2 ones. So at least 2 means 2 or more. And this has been tossed 4 times, so our n value is 4. So off to the side, n is 4. Let's list our R value. 2 or more, so that means 2, 3, or 4. P value, what's the probability of tossing a 1? at least 2 ones. Probability of getting a 1 when rolling a die, 1 out of 6. And probability that it's not a 1 is 5 out of 6. Okay, so we need 3 individual values with an R value of 2, 3, and then 4. And then we have to add all 3 of those up. You can write it out in one line horizontally with addition signs between them, or you can list it vertically. To save room here, I'm going to list it vertically. So this is going to be 4, choose 2, p-value 1/6 to the second, q-value 5/6 to the 4 minus 2, which is 2. I'm going to save the time on the calculator, and this results in 150 over 1,296. Next, R value of 3. 4, choose 3, 1/6 to the third, 5/6 to the 4 minus 3, which is 1. This results in 20 over 1,296. And lastly, 4, choose 4, 1/6 to the fourth, 5/6 to the 4 minus 4, which is 0. And this results in 1 over 1,296. So anytime you use a formula, you have to show substitution into the formula. So you need all of this. And then I'm going to add these up, so plus them. And that's 171 over 1,296. Or any reduced equivalent fraction, or decimal, equivalent decimal, are all correct answers. Next, same fair die is tossed 4 times. Find the probability of at most one number greater than 4. At most one number greater than 4. So at most 1 means 1 or less. N is still 4. How many successes are we looking for? 1 or less. 1 or none. 1 or 0. And we're looking for the probability at most one number is greater than 4. Greater than 4? Well, what's the probability of rolling a number greater than 4? Greater than 4, that would be a 5 or a 6. Well, there are 2 possibilities, right? So that's 2 out of 6. The probability that's not a number greater than 4, probability of failure, would be 4/6. Now I can keep these values, or I could reduce them. 2/6 is equivalent to 1/3, and 4/6 is equivalent to 2/3. Okay. Well, let's go to the formula. So it's going to be NCR, P to the R, Q to the N minus R. So this is going to be 4C1, P to the first, Q to the 4 minus 1, which is 3. That's going to equal, before we had the TI-84s, we had to work these out by hand, and I just know from practice that 4C1 is equivalent to 4. 1/3 is 1/3. 2/3 cubed is going to be 8/27. So 4 times 8, that's 32 over 81. And when our R value is 0, 4C0, 1/3 to the 0, 2/3 to the 4 minus 0, which is 4. 4C0 is just 1. 1/3 to the 0 is 1. And 2/3 raised to the 4th is 16 over 81. When I add these, and it results in 48 over 81. Next, number 3, we have Peter has a 40% chance of making a three-pointer in basketball if he shoots 6 three-pointers in a game. So he shoots 6 three-pointers in a game. What is the probability that he makes at least 4 of the three-point shots? All right, so he's shooting 6 attempts. All right, 6 three-point attempts. So our n value is 6. And we're looking for the probability he makes at least 4. At least 4 means 4 or more. So n is 6, 6 attempts. R is 4, 5, or 6. Our p-value, probability he makes a three-point, is 40%, as of decimals, 0.4. And the probability he doesn't make it, he's unsuccessful, is 0.6. So we'll find all 3 R values individually and then add them up. So 6, choose 4, 0.4 to the 4th, 0.6 to the 6 minus 4, which is 2. And I'm going to save the time keying into the calculator and tell you that this is equivalent to the decimal 0.13824. And then 6, choose 5, 0.4 to the 5th, 0.6 to the 6 minus 5, which is 1. Again, if you have a calculator at home, just key in a few of these, see that they match up. This is 0.036864. And 6, choose 6, 0.4 to the 6, 0.6 to the 6 minus 6, which is 0. This results in 0.004096. We add these 3 decimals, 0.1792 is the end result. Remember, probability is always between 0 and 1 inclusive. It can never be less than 0 and never greater than 1. Now part B, at most 4 three-pointers. At most 4 means 4 or less. Right? And there's 2 different ways of doing this, so I'm going to hold off on going over B on the video, and we'll go over this in class tomorrow. So let's skip over that for now and look at C and D. C is asking for what is the probability that he makes no three-pointers. So it's not an at least or at most question, it's an exactly none. So in which case our R value is 0. You get 0 three-pointers. So N is still our 6, R is 0, P is 0.4, and Q is 0.6. So NCR, 6, C 0, P to the R, 0.4 to the 0, Q to the N minus R. Go to the calculator. 6, math, probability, number 3, 6, C 0, 6, choose 0, times 0.4 to the 0, times 0.6 to the 6. 0.046656. And D, exactly 6 3-pointers, exactly 6, it's an R value of 6. N is still 6. P and Q are the same as they have been, 0.4 and 0.6. So 6, choose 6. 0.4 to the 6, 0.6 to the 6 minus 6, which is 0. Right. Pause the video or go to your calculator, key this in. This is 6, this is 0. Looks like a 6 to me. Point 0.004096. And this concludes our video for today. Thank you.